Before going to the cubic formula of a plus b, you need to know the square formula for a plus b. And what you can see on your screen is the square formula of a plus b, that is a plus b whole square, where the blue square represents a square, the turquoise square represents b square, and the two lemon green rectangles represents ab. Since two rectangles are there, hence it is twice ab. And the entire area, which is a square of sides a plus b, is the formula for a plus b whole square. The cubic formula is three-dimensional. The most common one is for volume, which is measured in cubic centimeter, cubic meter, and any such units. So to get the idea of dimensions, let us just take a few seconds to see the point which has 0 dimensions. That is, it doesn't have a length or a breadth or a height. If we extend this point on a direction, we shall have a line which has a dimension called length. The line has a length, but it doesn't have a breadth. But if we extend a line in a given direction, that will give us a breadth, which along with length gives us an area. So have you ever thought what would happen if we extend an area? When we extend an area in a particular direction, we get the volume, the 3 dimension, which has the length, the breadth, and a height. Now we have an area here, and let us verify this by extending this area. And this area is already known to us, which is a plus b whole square, and we are going to extend to a length of a plus b only, so that it becomes a plus b whole cube, and we get a cube whose all the dimensions, that is all the sides, measures a plus b. As I already told you, area is a two-dimensional quantity, hence if we rotate it, we shall not have any height. But yes, you can see here there is a little bit of thickness that is only for us to see. If I don't give any thickness, which is practically not possible, yet if I don't give any thickness, that would mean that you won't see anything from this angle. Just for the sake of the eyes, I have given a thickness, and we are going to extend this length to a plus b. And we know that the blue square had the side a and the turquoise square had the side b. Hence we are extending it to a length of a and b. From this angle, it looks like a square. However, this is not a square, it's a cube. It is a plus b whole cube, and you are going to see it when I do some painting. Let me paint the corner of this cube, the right top corner of this cube, orange, and the left bottom square with lemon green, whose size would be same as a square. And then we shall have two rectangles, and I will paint both of them turquoise. And now you will see how I break it down into the parts of the cubic formula. A plus b whole cube equal to a cube plus thrice a square b plus thrice ab square plus b cube. But hey, we made a cube, and a cube is a three-dimensional object. So why are we viewing in 2 dimension? Let us go to 3-dimensional view and see what we made. Look at that left face of the cube. You remember that the blue square, the turquoise square, and 2 rectangles lemon green in color, which was our a plus b whole square. This portion was being extended to make the a plus b whole cube. It can be sectionalized in this way so that we can get out our formula of a plus b whole cube. Let us now separate these sections so that we can study them individually and see how we can get the formula of a plus b whole cube. Let us take this orange cube out, whose sides are equal to b, which you can clearly see from the 3D figure. Hence a cubical shape is being taken away from a plus b whole cube. Now we take away the a cube, because this a square was being extended to a length of a, hence it is a cube. Now the turquoise blocks, whose one face is equal to b square, and it was extended to a length of a, hence the cross-sectional area of these cuboids are b square. It is being extended to a length of a, hence b square into A will be the volume of this cuboid. Then these three lemon green blocks whose one face is clearly seen to be equal to A square, and it was extended to a length of B. Hence the cross-sectional area A square into the extended length B would give the volume of this lemon green cuboid as A square B. So we have a A cube, we have a B cube, and now by simple rotation and change of position I am going to show you that these three turquoise cuboids are equal to each other, and those three lemon green cuboids are also equal to each other. As you can see, all I am doing is some rotation and changing of the position of the cuboids, and here in this case you can see the one face of this turquoise cuboid is same as one face of the lemon green cuboid. But are they equal? No. When we rotate it, you can see that the cross-sectional area of both the cuboids are different. One is A square and the other is B square. Obviously it won't be difficult to prove that the three lemon green cuboids are equal in volume, which is A square B. Hence for three lemon green cuboids we can write thrice A square B and kick off the other two away. Similarly, the turquoise cuboids which has volume of B square A, why did I choose these colors lemon green and turquoise? God knows. Anyway, we can kick off this turquoise and this turquoise cuboid too. Finally, we have these four shapes: A cube, B cube, A square B, and AB square. However, we had 3 A square B and 3 AB square, hence we write 3 A square B and 3 AB square. Two things that I presume that you know is the volume of a cuboid, which is length into breadth into height, and the volume of a cube, which is side cube. Now if you notice, this is a cuboid whose cross-sectional area is known. It's B square, and when it is being multiplied to a height which is equal to A, then that volume is B square A, or we can also say that AB square. And this cross section is nothing but length into breadth. However, the length and breadth are same, both are A. It is A square and it is being extended to a length of B, hence the volume of this cuboid is A square B. And the volume of the cube is well known because all the sides of this cube, three sides, the length, the breadth and the height, and all this length, breadth and height is equal to A, hence this is A cube, and hence we got the formula of A plus B whole cube as A cube plus thrice A square B plus thrice AB square plus B cube.